Hello viewers, welcome to the part 6 of the step-by-step Oracle Data Guard series, and in this part we are going to cover standby database modes. So viewers, in this series I am covering various topics on Oracle Data Guard like architecture, implementation, administration, management, monitoring, etc., which I am listing below. Each of the topic may need one or more tutorials to cover it completely. I assume you are already an Oracle DBA or familiar with at least the basics of Oracle database architecture. I will keep everything simple so there won't be any difficulty in understanding the concepts even if you are a beginner. Please note that whatever commands I am using in this tutorial, they are all available in a shared document in my Google Drive. You can access that using the link in the description of this video below. Moreover, I am using Oracle Enterprise Manager extensively in this whole series. If you want to learn more about OEM and become a master in OEM, starting from installation, monitoring, alerting, upgrade, patching, etc., please watch my 16-part YouTube series named Mastering OEM, for which I have given the link in the description of this video below. Before I start the demonstration, let's first get familiar with the test environment that I'm using. In this demo, the primary and the standby databases are with DB unique name testdz1 and testdz2 respectively, and they are created in Oracle Database version 19.3. For monitoring and management, I am using OEM version 13.5. All the database and OEM servers have the 64-bit Oracle Linux 7.9 installed. I am doing all these demonstrations in my virtual environment created using Oracle VirtualBox virtual machines. If you want to create your own virtual learning environment, please watch my tutorials using the link given in the description of this video below. So far in this series, we created our data guard environment, learned about configuration, switch over, failover, monitoring, primary database protection modes, etc. If you have not watched the previous parts in this series, I suggest you watch them first to get a better understanding on what we are going to discuss in the next. Now let's start with the main topic of this tutorial, that is the standby database modes. Let's first understand what are the different modes of a standby database. So a standby database can have three modes of operation, which are mount mode with or without redo apply, read-only mode with or without redo apply, snapshot mode with no redo apply. To understand these modes, we need to understand first the Oracle database startup stages. In the Oracle database startup process, the lowest or first stage in terms of accessibility is the no mount stage. During the no mount stage, the Oracle memory structures and background processes are started, and only the initialization parameter file is accessed and read in this stage. In this stage, the instance is accessible only to the sys user, who can take it to the next stage or perform certain recovery operations that include the control file recovery also. The second stage in the startup process is the mount stage. During the mount stage, the control files are read and data files are located from control file but not opened. In this stage, also, the instance is accessible only to the sys user, who can take it to the next stage or perform any recovery operations on the data files. The third and the final stage in the startup process is open stage. During the open stage, the data files are read and opened. In this stage, the instance is accessible to all users for normal operations. The database startup process must pass through all these three stages to be open and become available for normal use. You may start the instance in no mount stage, then go to the mount stage and then finally open it, or you may mount then open it, or you may directly open the instance, but that does not mean you can skip the previous stages, because even if you start the instance directly in second stage, that is mount, or third stage, that is the open stage, internally it must always go through all the previous stages. Now you might understand why a standby database needs to be in the mount stage, because it needs to continuously recover itself, or more precisely the data files, with the redo data that it receives from the primary. Now let's understand the standby database startup stages. In this diagram, all the commands are given in the yellow boxes, and these commands actually work for the primary database also. unless standby database option is specified. Please note that a standby database cannot be opened in read-write mode without activating it first, usually in the event of a disaster when your primary database is completely destroyed, or as a snapshot standby, which we are going to discuss in a few minutes. So for a standby database, first from the shutdown state of the database, you may use startup no mount command. Then in the second step, you have to mount the database using either alter database mount or alter database mount standby database command. Then in the third step, you have to open the database using either alter database open or alter database open read only command. If you just use alter database open command, the database by default will be open in read only mode. You may also directly go to the second stage and use the startup mount command. Then in the third step, you have to open the database using either alter database open or alter database open read only command. You may also directly go to the third stage and use either startup open or startup open read only command. Again, if you just use startup open command, then the standby database by default will be opened in read only mode. And in the stage number 2 and 3, redo apply or the MRP process is automatically started if DataGuard broker is in place. Otherwise, you have to start it manually. When you open a database in read-only mode with redo apply on, it is called active DataGuard, which requires additional licenses from Oracle. Now let's see these stages in action one by one along with their behavior in 3 different ways from the point when the database is in shutdown state. First, we will start the standby instance in no mount mode, then mount and then open. Second, we will mount the instance, then open in read-only mode. And third, we will start and open the instance directly. Now, let's implement this with actual commands. Let's take the first scenario, where we will start up no mount the database. Then we will do the alter database mount command, and then we will use the alter database open command. I established 2 SSH sessions to the standby server as Oracle user, who is the owner of all Oracle installations in the OS level. The OS environment has been set for standby database instance. I will establish the first session to the standby database using SQL Plus as sysdba, and I will establish the second session to the standby database using DataGuard Manager command prompt as sysdba. Now let's take a look at the DataGuard configuration using show configuration, and we see that the configuration is clean, and we see that the protection mode is max performance. The primary database is testdg1 and the standby database is testdg2. Now let's go back to the SQL prompt, and now first we will shut down the standby database. Now the database is shut down and we will start up no mount the database. So the database is started in no mount stage. Now we will do the alter database mount command. The database has been altered, and now we will open the database. So the database is altered, means it is open. Now let's check the database role and the open mode, and we see that the database is in read only with apply option. So as expected, when we open the standby database, by default it will open in read only mode, and the DataGuard broker is in place, so the redo apply has been automatically started. Let's check the status of the MRP process, and we see that the MRP process is currently applying log sequence number 193. Now let's take the second scenario, where from the shutdown state we will start up mount the database, and then using alter database open read only we will open the database. So first we will shut it down. So the database is shut down. We will start it up in mount mode using startup mount command. Now the database is mounted and we will use the alter database open read only command to open it in read only mode, and we'll see the status of the MRP process. Now the database is altered and we will use the same command, and we see that it is again open in read only mode with redo apply. Let's check the MRP process status again, and we see that it is applying the log sequence number 193. Now let's take the third scenario, where from the shutdown state we will directly start up the database and we'll see in what mode it opens and the MRP process status. Again, we'll shut it down first, and it's shut down now, and we will directly start it up with open option. So it is open. Now let's check the open mode, and we see it is read only. The MRP has not yet started. Let's give it a couple of seconds. Yes, now the MRP has started. Let's check the status of the MRP process again, and we see it is currently applying log with sequence number 193. Because there has been no log switches in the primary, so we saw that in all these three cases the log sequence that was being applied was 193 only. So now we have seen how the standby database can be either mounted or opened in read-only mode with redo apply on. Simply mounting the standby as a physical standby with redo apply on has advantages like you can offload the primary by moving the ARM and backups to the standby. We will cover this in the part 7 of this series. However, opening the database in read-only mode with redo apply on, which is also called an active data guard, also has additional advantages. For example, you can offload the primary by moving applications that need read-only access to the data like reporting applications, etc. But as mentioned earlier, it needs additional licenses from Oracle. Now we learned how to open the standby database in read-only mode, but is there a way we can open the standby database in read-write mode? Of course, you must open the standby database in read-write mode in the event of a disaster when your primary is no more accessible and you need to fail over to the standby database. But that is a permanent role change where the standby will no more stay as a standby anymore. It becomes the new primary, and we have already covered that in the part 2 of this series. But there is another way to temporarily open the standby database in read-write mode without affecting the data guard integrity. It is called Snapshot Standby, when the redo apply or MRP is stopped temporarily in the standby. Converting the standby to a snapshot standby and opening it in read-write mode has implications because you will compromise the recover time in the event of a disaster, as you have to first apply the pending logs that accumulated when the MRP was off during the standby's snapshot mode, and then you can fail over to the standby and open it as new primary. But the good thing is you can actually switch the modes of a standby database between its physical standby mode, which is either mounted or opened read-only with MRP on, and snapshot standby mode, which is opened read-write with MRP mandatorily off. Now let's see how to convert or switch between the physical standby and snapshot standby database modes. There are 4 different methods to achieve this. First, using OEM. Second, using data guard commands. Third, using SQL commands. And fourth, using complete manual steps. In this series, as we are mainly emphasizing OEM techniques, so I will show you the first method using OEM and the second method using data guard broker commands. The full commands and steps for the third and the fourth methods are given in the description of this video below, and if you want, you can copy those commands from there. So let's start. First, using OEM. I logged into my OEM system as sysman user. Then go to the home page of any of the participating databases in the data guard configuration. I am in the primary database with DB unique name testdg1's home page, and then go to availability. then DataGuard administration page. Here we can see that the primary database is testdg1 and the standby database information is below, which is testdg2. Now here we see this convert button. Click on the convert button, and in the next screen it will ask for the operating system credentials, that is the Oracle users credential that we created as a named credential. We saved it as NC Oracle Global in the previous tutorial. Let's select it and click on the continue button. And then in this screen it will give a warning. This operation will convert the last physical standby database to Snapshot Standby and all the details. As I mentioned before, converting the physical standby to a Snapshot Standby compromises the recoverability time. So this warning is about that. So we will safely ignore this and we will press the yes button to confirm the conversion. So click yes, and it will take a couple of seconds while it is converting the database to Snapshot Standby. And once this process is completed, it will take us back to the DataGuard administration page. And we see the information here, the conversion process is complete. And now we can see in the standby database section below, the testdg2, the standby is currently in the role of a snapshot standby. Now let's do a couple of experiments. First, I will go back to my SQL Plus session. I have to log in to the standby database as sysuser because the previous SQL Plus session has been expired. So SQL Plus / sysdba, and this is my standby database. Let's check the role first using select name database role open mode, and here we can see that the database role is snapshot standby and the open mode is read write. Now I want to show you something interesting here, and that will be from our $v restore point view, and upon querying, select SCN time name guarantee flashback database from $v restore point. We see that there is a guaranteed restore point automatically created with the name snapshot standby required and the time when we actually converted our physical standby to snapshot. And we see guarantee flashback database is yes, so it's a GRP or guaranteed restore point. This GRP plays a key role here as Oracle keeps track of all the changes happening in the database from this GRP onwards. And when you convert the database back to a physical standby, Oracle will roll back all the changes after the GRP or flashback the database to this GRP. Now I will create a small table for testing purpose, that is create table tx as select 1 as n from dual. So the table tx is created and let's query the table. We have just one column called n and the value there is 1 with one record. Now we'll update this. Update tx set n equal to 2 and we'll do a commit, and everything is working like a normal read write database now. So you see we can do data modifications in the standby database as a regular database that is open in read write mode and which is actually in snapshot mode now. Now to convert this snapshot standby back to the physical standby mode, all we need to do in OEM is to go to the DataGuard administration page and there select the standby database, then click on the convert button, which will convert the database back from snapshot standby to physical standby. Now we see these warnings here which says transport lag has exceeded specified threshold, which is expected because currently MRP is off. Now if you click on the convert button, Like the previous time, it will ask for a confirmation first. Once we select the name credential and click on the continue button, it will ask for a confirmation to convert. But this time we will not convert it using OEM. So click no. And instead, we are going to use the DataGuard broker command to convert this database back to physical standby. So let's go back to our SSH session where we connected to the standby database using DataGuard manager command prompt. But this session might have been expired. So I'll have to connect again. Let's check the configuration again. And we see this warning message here also. Transport lag has exceeded specified threshold. Now to convert it, we'll use the command convert database test dg2 to physical standby. So this convert command is quite simple. If you need to convert a physical standby to a snapshot standby, all you need to do is to switch these clauses here, like convert database test dg2 to snapshot standby. And we are doing the opposite right now because conversion to the snapshot standby has been done through OEM. And we are doing the reverse activity in DataGuard manager command prompt. Although this command is quite simple as it looks like, internally it is doing quite a few steps, as you can see, like shutting down the instance, mounting it back, then convert it, which again may have multiple discrete steps. And we see the last message here, database test dg2 converted successfully. Let's check the configuration again. There are a couple of errors which should go away momentarily. Just allow it a couple of seconds. Let's repeat the command again. And yes, now everything looks green and clean. The protection mode is max performance. Test dg1 primary database, test dg2 physical standby. And that's how we can convert a snapshot standby to physical standby using DataGuard broker command. Now let's go back to the SQL prompt again. And we have to reconnect. Because the previous session was expired or terminated because the database was actually restarted when it converts from physical to snapshot or snapshot to physical. Now we will check our table again, and this table should actually now go away, and we see yes, table or view does not exist. Also, let's check the $restore point view if the GRP is still there, and there is no GRP currently. So we can conclude that when we converted the database back from snapshot standby to physical standby, all the changes that we did in the database after the GRP was created have been rolled back, and the database was flashed back to the GRP, and also the GRP was dropped. Now let's go back to our OEM console and refresh this page, and we see everything is back to the state as it was before. So this is all for today. In the next part in this series, we will cover how we can configure RMAN backups in the standby database to offload the primary. So viewers, please provide your feedback in the comment section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.